Good afternoon, everyone. Welcome to the 102 stream. This is the first session of our virtual conference. Today's session is an introduction to zOS BCPii, and how to control your Z hardware programmatically. Or is it programmatically even? Sorry. Steve's happy to take questions throughout, so I'll keep an eye on the chat, and I'll be able to relay them back to Steve. But without further ado, yeah, Steve, if you want to crack on, and we get underway.
Sure, thank you, Mr. Knowles. Hi, I'm Steve Warren, as was mentioned before, and I'd just like to welcome you to this introduction to something called BCPii. You may have heard of this when folks are talking around the water cooler or just about that terminology referenced before, but you might not know what it is. We're going to dig down and learn exactly how this can affect your Z ecosystem. And so I will, being from the States, sometimes I do use the last letter of the alphabet as Z instead of Z. So you have to give me some latitude there when I say that, because it's a habit of us folks in the States calling it that. So let me just tell you a little bit about myself quickly. I am an STSM and a architect working in an area called client engineering for systems. And we just help clients embrace the latest technologies on the Z platform. I am the founder of the BCPii component in the zOS operating system. And so we're going to be focusing on exactly what this is all about and how does this really apply to my day-to-day job. And hopefully you'll learn a little bit more at the end of this session. So please feel free to put questions in the chat, and we will get those questions relayed to me. Okay. Without further ado, let's just take a look at what the agenda is going to look like for today. So first, we're going to just have a real quick overview of the mainframe. And you'll say, well, I know about the mainframe, but sometimes we need to level set terminology about when we're talking about the various constructs involved with the mainframe. So we'll talk just about a really high level view of that. And for some of you guys, you can go to sleep for a couple minutes. Others may be just a good refresher about some of the terms that are used. And why do we need these terms? Because BCPii is going to interact with these things. And I like to define words first before I use them in a sentence. And for those that may not know it, so we'll go over just quickly that. We'll talk very high level view of what BCPii is and a little bit how it works. We won't go too much into detail with that today, because we're trying to give a pretty high level view of what's going on. And then we'll talk about how is it being used today, and how would you even, whether it's a vendor product or whether it's IBM operating system or whether it's your own application, how do folks use BCPii today? Another thing is, how do I install or activate it? So this is a big issue. Okay, so I have this BCPii is available to me, but do I need to do anything to get it ready for me to actually use? And so we'll talk about the various personas that may need to get involved in actually standing up BCPii for the first time. And then how do I maintain it? How do I do operations? How do I debug application programs and whatnot? Okay, does that sound reasonable for an agenda today? So let's just dive right in. All right, mainframe overview. So this slide is just showing that we've gone through an evolution of different mainframe boxes over the number of years, starting many years ago, iterating all the way up from the these are Z9, Z10, Z196, ZEC12, Z13, Z14, Z15, and introducing, of course, the latest machine, the new Z16, which can be in many different configurations, from a small 1-frame to a 4-frame. Now, why we talk about all that is because BCPii has the ability to interact with this hardware no matter what the level of the hardware is. So all the way back to that very early, if you go back to the previous page, to that very early box that was around many years ago. Of course, you can't have a parallel sysplex with a very old machine and a very new machine in the same sysplex, but BCPii is kind of agnostic to the hardware per se. We don't care what level the hardware is, as long, of course, as you are trying to leverage a particular feature on that machine. Of course, that feature needs to be in existence, or else it's going to give some kind of a failure. So the bottom line is here, the whole point of all these charts is simply to illustrate that BCPii can work with any level of Z hardware that is available. Now, a Z15 and a Z16 look very similar on the inside. So just talking about some things, I'm not going to talk about most of this stuff. The thing that we're going to be focusing in on is this thing called a support element. And that is located inside of one of the frames. If you only have a single frame, one, it's going to be in the frame. But this is a 4-frame model. And in this frame, in the upper section here, there's a thing called a support element. All this hardware, whether it's the power supplies or I/O configuration or CPC and drawers that contain the necessary CPUs and a lot of the other infrastructure, cooling, etc. All of this stuff is controlled by something called a support element. And these are just two little blade servers that are at the top. And here's a little drill down. These blades that are in there run a Linux operating system, and they actually provide the interface whereby we can control this hardware and make modifications to the hardware configuration, to view the hardware configuration, etc. So this is kind of, you can think of the gateway into being able to control and manage the configuration that you have set up for your mainframe. And this can manifest itself in many ways. And so we'll talk about some of those ways that you can control, that the configuration can be modified. And so someone typically, again, a support element, a dedicated machine for monitoring the operating, it's integrated within the same frame. And there's two of them so that you have the ability to have backup just in case one fails. And so the way you could interact with a support element would be actually to log in. And so you have the ability on a Z14, they have this swing out a display and keyboard, which interacts with that blade that allows you to make configurations right at the unit itself. Very uncommon for you to use that interface. In a Z15 and Z16, they have this idea of you can have a keyboard and mouse can be actually inside of this cubby hole that you have, that you can pull out, and the support element is actually is right here, for example, and you're going to be interacting with that machine, and you just plug in to a particular port, and you're able to access and control the configuration of the machine through a graphical user interface. And you can think of it kind of as this. And so a bunch of support elements, one support element for each CPC machine that you have on in your data center, right? And all of those support elements can be controlled through a single console called the hardware management console. The hardware management console is a way to access all those support elements. So the support element is actually managing the configuration of a particular frame or a particular Z box, and the conglomerate of all of those boxes that you have in your machine can be controlled by a single screen connected to a LAN that allows us to have this control from a single point. We call that, again, the hardware management console. So what is the hardware management console? You can think of the hardware management console and or the support element as kind of the control panel of the Z hardware. So in Windows, for example, you could have Windows, or you could have, of course, you could have a Mac OS. But in the case for Windows, we normally go into Windows settings, or what used to be called the control panel. And through that control panel, I'm able to manage the configuration of my Windows machine, the hardware. In particular, I can set up the characteristics of that hardware through the control panel. Likewise, you can do a lot of the similar functions through something called the hardware management console, which is basically an interface that allows us to access a support element on each one of these CPCs. So the hardware management, again, a centralized manager. It communicates through the CPC support element. The HMC directs the commands to one or more SEs, which issue those commands to their CPCs. And one HMC can control up to 100 CPCs, and it connects via a network in a browser or directly, or you can actually use APIs to interact with the hardware management console so that I can do things through a REST interface. So on a Z16, this HMC also is not a separate piece of hardware necessarily, but it's actually inside the mainframe itself. And that piece of hardware, known as a hardware management appliance, actually resides in one of the frames, but it has the ability to control a whole bunch of those other frames. So a support element dedicated to a particular CPC and a hardware management console / hardware management appliance, that is the ability, that is the blade that is going to be communicating to all of those support elements. Okay, so why does that all matter? Well, BCPii, as you're going to see in a while, communicates directly with a support element. It does not communicate through the hardware management console or hardware management appliance. This is an important distinction. So wherever I'm going to be running a BCPii application, you're going to see in just a few moments about a little more details, that BCPii application is actually going to be communicating with the support element that is on the local machine of where that zOS application is running, that's issuing the BCPii constructs. We'll talk more about that in just a few moments. Now, let's also talk about a few other definitions. So there's something called logical partitions on zOS. Okay, that's simply abbreviated as LPARs. This is the division of the computer's processor, memory, and storage into multiple resources, and each are virtualized as a separate machine. So each LPAR is operated independently. So I can have multiple partitions on a single Z machine. In fact, almost every single client known to man does not run their mainframe or something called a CPC. They don't run that as a single operating system and a single, no division of the hardware. Instead, they run multiple instances of different operating systems on the same machine, divided up as LPARs. You can think of that in the analogy of being able to dual boot your laptop, for example, and the ability to have sometimes more than one operating system. Like, for example, I could have Linux and Windows, for example, on my laptop, and I can choose to boot one or the other. The difference with the mainframe is that I'm running all of these things in parallel, and so I can have multiple of these machines running. So another name for an LPAR is sometimes called an image. So an image is just another term for a logical partition, as far as we're concerned in this presentation today. And then we have something called activation profiles. And just to round out the definition of some terms before we get into what BCPii is, an activation profile is really a saved configuration. And it represents a saved way of how I want to bring up a particular CPC or how I want to bring up a particular LPAR. A CPC, again, means the actual entire box that I showed you on those first pictures, a picture of a Z15. That entire frame, that mainframe, is a single CPC. And so then that single CPC can be divided up into many different LPARs. And those LPARs are also, there needs to be a way of how do I bring up those LPARs so I have a consistent way each time I need to reboot that LPAR. There's a consistent way that I'm going to be doing it. And again, I want to tailor the operation of the CPC. I store these activation profiles on my support element. Okay, and there are 4 types, and I won't go into a lot of details about that because this purpose of this presentation is not so much about hardware, but it is about understanding the types of things that you can control using BCPii. And so I will just mention that there's reset, image, load, and group activation profiles. Okay, so I've done a lot of talking about the hardware. Are there any questions that have been asked in the chat so far?
Nothing so far, Steve.
Okay, yeah, perfect. Okay. All right, now that we sort of level set our understanding of what a CPC is, what an LPAR is, what an activation profile is, what a support element and hardware management console are, now let's talk about what BCPii is. BCPii is a programmatic interface that is going to allow a authorized zOS application. We're going to talk about what the word authorized means in just a moment, but a very privileged application running on zOS or zOS. It has the ability to actually monitor the performance of the system, to monitor any changes that have occurred in the configuration or in the status of a particular in the configuration. It's able to learn what the configuration is. It's able to change the configuration. It's able to reboot or re-IPL a particular image. I can change capacities. I can update many various settings, whether it's activation profiles or other things. There's all kinds of power that I can do with various functions within BCPii. So this is a programmatic way. Instead of using the HMC SE support element control panel form, which is a graphical drag and clicking and selecting and doing that type of UI interface. Instead, I'm going to do this in an automated fashion. We're going to see why it's so important to be able to do things in automated fashion. So let's just dive in a little bit more. Okay, so what does BCPii actually stand for? Well, it stands for something called the Base Control Program Internal Interface. So the base control program of zOS is something called the BCP, and that is the guts of the zOS operating system. And basically what this is saying is this piece of software that allows us to communicate with the hardware is embedded within BCPii, and it's an internal interface directly to the hardware. So we'll talk a little bit more about what that means in just a moment. So very special programs on zOS can have this HMC-like control over their system, over any system that's in the HMC LAN. So if I have, let's say I have 3 mainframe boxes on my raised floor in my data center, and they're all connected in the same HMC network. If I provide the proper authority, both on the HMC, on the individual support elements, and in BCPii, I can actually affect change on any or all of those systems with my zOS application running on just one of those systems. In order to do that, I'm going to need program authorization and security authorization on zOS, as well as authority set on the support element that gives me that right to be able to control those from my particular LPAR where my zOS application is running. So if I have a zOS instance running on a particular mainframe on the box, I have to be given that I can control even my own LPAR, as well as other LPARs, as well as other LPARs on the network in the data center. So a set of authorized APIs is provided that allows this authorized application programs to use. So there's some internal APIs that BCPii provides. We'll talk more about that in just a few moments. One of the key distinctions of BCPii is that it does not use any external network. And this is a very critical design point that's worth exploring just for a few seconds. BCPii does not use TCP/IP to communicate with the support element or with the HMC. This is a distinction that is very interesting. So instead, it uses a direct interface to the hardware through the lower levels of the operating system, and actually issues a hardware machine instruction to actually facilitate that communication. This means that BCPii has about as close to 100% availability as you're going to have. And there's nothing to do with networking outages or anything of that nature. Obviously, the operating system needs to be able to talk to the hardware. And if the operating systems can't talk to the hardware through this BCPii channel that it uses, you have bigger problems than BCPii. So the idea is close to 100% availability, and also a 100% secure interface between the operating system and the hardware. There's no need to necessarily open your HMC to an outside network or anything else to use BCPii, I can run my application and be able to have control over that hardware without ever going through any networking on the system. So this is a very important design point, and why BCPii has gained a lot of popularity over the years is because of this direct connection that it has. Okay, the next point is, well, I'm sorry, I trigger happy there, is that there's a zOS address space that manages this authorized interaction with the interconnected hardware. So on the system where I have my BCPii application, I need to have the BCPii address space running. And so that BCPii address space, which will start up, we'll talk a lot more about this in just a few moments. It'll try to start up during the IPL or boot of the operating system. Will manage the interaction that your application programs that use BCPii APIs and that interaction with the hardware. So you need to have that address space up and running. All right, now I keep mentioning you need to have program authorization and security authorization. And so I want to just talk a little bit about the distinctions about why we need to have both of these in zOS. So let's first talk about program authorization. So in zOS, the installation identifies systems or user programs that can use sensitive system functions. And the way they do that, you need to be authorized in something called the APF list, the authorized program program facility. An application is listed in this particular list of data sets. So of course, zOS has data sets, and applications that are in these particular data sets are certain data sets are given special authority, and that special authority allows them to basically do whatever they want. They are kind of an extension of the operating system. So anything that is what we refer to as APF authorized means that that application really has the same authority as the operating system, and it can do all kinds of things. It can modify system control blocks. It can issue privileged instructions. It can turn off logging. Obviously, this is for very, very special programs. And BCPii is special because it has lots of authority. You can do things that are more powerful than just about any other program on the system. So I used to say, oh, the ultimate API for the power-hungry person, right? Because I can with BCPii, I can do things like re-IPL a LPAR and its operating system. And that operating system doesn't even have to be zOS. It can be any operating system that runs on the Z platform. So that could be a native Linux, it could be VM, it could be TPF, it could be VSE, or it could be another zOS operating system. And it could be on, if I have the proper authority, I can do things besides IPL. I can actually change timer settings, which can cause really bad things to happen if you don't set it right. I can even power off an entire mainframe through a BCPii application. So obviously, with this amount of authority, we need to make sure that this is running as an extension of the operating system. Now, that's not enough. Just because you're in the authorized program facility, your application is in a data set that is in the APF list. That is not good enough, but it is a first requirement in order to even consider being able to allow the application to do the function it's trying to do. Now, let's contrast that with security authorization. So within zOS, there is the concept of SAF. The Security Access Facility allows you to be able to interface with one of the three major security products that are available on zOS. So two are produced by Broadcom. One is called ACF2, and another is called Top Secret. And then a third one is IBM, and it's RACF. These three provide the authentication and means to be able to ensure that a person is who they say they are when they log on to the system, and to provide that basic authentication. And do they have authority? Not only can they log on, but can they access certain resources that are available on the system? So in addition to the program authority that I need to have that says that this program is an extension of the operating system, I also need to have had the system administrator to give the necessary authorities to your particular application to be able to run that. And so their different authorities can be given for different types of requests. So this allows me to, for example, to be able to view the hardware configuration, but not update the hardware configuration for a particular LPAR, for example. And on my own little test LPAR, maybe I'm given write authority to be able to do, or even to have authority to do very powerful commands such as re-IPL or change major settings. So again, that it can be given for a particular CPC, LPAR, etc. Now, the third level of authorization. So now, from my operating system's perspective, those first two things say, yep, this guy is basically an extension of the operating system. It is program authorized. Yes, the security admin has given them the authority to be able to do those things, but that's not good enough. And the reason why that's not good enough is because if I'm in a shared environment, well, let's say I run in a service provider environment where one company services multiple other companies' LPARs. So I'm going to use the example of Coca-Cola and Pepsi, and this is just a simple illustration to bring a point home. Two competitors that maybe don't want to have their own LPARs, and so they have Coca-Cola has a set of 3 LPARs on a service provider's machine, and Pepsi has 2 LPARs on that particular machine. So Coca-Cola does not want Pepsi looking at their LPARs, and vice versa. Pepsi doesn't want Coca-Cola looking at their LPARs. And so what we have to do is, just because the Coca-Cola system programmer has granted an application on that Coca-Cola LPAR program authorization, and the security admin for Coca-Cola has granted security authorization, doesn't mean that that application should be able to access the Pepsi LPARs. And so we have to do more than just have the Coca-Cola folks say, yeah, they can access anything. We have to have also the ability of the engineer that controls the entire mainframe box to say, these LPARs can issue requests to these other LPARs. So I'm going to let Coca-Cola to be able to access all of the Coca-Cola LPARs, but I'm not going to allow them to access the Pepsi LPARs. So that's just an idea of what we're talking about here. It's not good enough that the sysprog and the security admin have given you authority. The admin of the entire mainframe, or sometimes the SE engineer or something like that, has to give that authority. And so this is basically what these things say. So prior to Z14, the security was not as granular, and that shared configuration I talked about, where you have a hosted environment, was not really practical for BCPii, because once I gave authority from a program and security authorization on the local zOS operating system, I basically had the ability to then access everyone else's stuff. And so starting with the Z14 and later, we've had that control. So we'll talk a little bit more about those controls in just a few moments. So now that we have the proper authority, the SE engineer has granted us the authority to be able to, which LPARs can access which other LPARs. If I have a BCPI application, for example, running in LPAR A, what other LPARs can it access? And then the system programmer and the security admin have given the necessary authorities. Now, in theory, I can run. So what does it look like when I actually run an application? So I'm going to have a user program. It can be in any address space on the system. That can mean it can run on zOS Unix. It can run in a traditional zOS batch application. It can run as a started task. There's all kinds of environments that you can run a BCPii application. The key, again, is the application has the proper authority. Once the application issues a BCPii API, what's going to happen is we're going to go in, that request is going to flow over into the BCPii address space, where we're going to check the security and make sure you have authority to the type of request you're doing. And then we're going to go through some lower levels of the BCPii address space that get that request ready to be sent as a hardware instruction to the actual support element. So once we've massaged that data and gotten it into a format that the support element can recognize, we then will issue this hardware machine instruction. It will actually flow over to the support element, and the support element will receive that request. If it's on a Z14, they're going to do additional security checking to make sure that this request coming from this LPAR can access the thing that you're trying to access. And then at that point, the request will be satisfied. Okay, that's a real high level view of what BCPii does, but how do I use it? Any questions before we proceed? Okay, let's continue. So, who uses BCPii today? Well, there are a number of functions that use BCPii. So let's talk about some of those right now. So we have parallel sysplex. Parallel sysplex uses BCPii, and if you have BCPii configured properly, you actually can do pretty amazing things to improve availability of your parallel sysplex using something called system status detect. That uses a BCPii function, and it's probably the first function that most clients use that exploits BCPii and requires you to do a little of the configuration that we'll talk about in just a couple of moments. So using that system status detect, I'm able to avoid when there's, for example, I'm not all the systems within a sysplex. So I have multiple LPARs that are all working together to process a workload. And when one of those systems goes down, sometimes the other systems want to do cleanup, but they're not sure exactly, is that guy really down, or is he just super busy and he can't respond right now? How do I know if that system is down or not? I'm not receiving any heartbeats from that other system in the sysplex. So what happens is that the operating system will wait around for a while before it actually does something. That's called the sysplex failure manager will wait what's called up to what's called the failure detection interval, which is usually about 3 minutes, which will then determine, okay, if I don't receive a heartbeat from any of the other systems in the sysplex, after 3 minutes, I don't know what to do. So what will happen is you'll get this message eventually on the console that says, I haven't heard from this guy in a while. Reply down to remove this guy from the sysplex and partition him out. And the reason why you want to partition him out, of course, is because if that guy's holding sysplex-wide resources, he could be creating a sympathy sickness condition within all the members of your sysplex, because these other systems, while they're up and running, they require resources that are currently being held by that third system. So with BCPii, of course, I can actually programmatically reach out to the hardware and say, is that guy still alive? If he isn't alive, get him out of the system out of the sysplex as quick as possible, and let's get him re-IPL'd. Let's collect the diagnostic data, and let's move on. Let's not cause this sympathy sickness that's occurring with the other systems. An example, and I went into great detail with that, just because I want you to understand how a particular application, or in this case, an operating system component such as parallel sysplex, can use BCPii. zOSMF has a discover CPC function, for example, that is used in many different aspects of zOSMF. That I can learn about the topology of my HMC network configuration, and so you can use that function. There's capacity provisioning manager that uses BCPii. There's HCD uses BCPii. Several operating system components use BCPii. There's also a whole lot of vendors that use BCPii under the covers, and they require you to do some BCPii setup if you haven't already done so. So whether it's enablement automation packages, for example, shipped by Broadcom or BMC or many of the other large software vendors, Hitachi and many others, whether it's a performance managing software like Z Price Manager, Z Cost Management, and many others, they all leverage BCPii under the covers and require you to do BCPii setup. So there's these set of things, whether it's the operating system or a software vendor, that's going to require you to have BCPii up if you want to use the particular feature or functionality that they're illustrating. The third set, and where we have a lot of usage also, is people writing their own BCPii applications. So you can code a C, an assembler, or Rex program that utilizes one or more of these various BCPii APIs that I'll talk a little bit more in just a few moments. These APIs let us to access that particular hardware. So either you roll your own or you buy a package that's already using BCPii. In all three of those cases, you're going to need to be able to configure BCPii. So here are just some of the sampling of the features that you can utilize in BCPii. So some folks will do it to generate a report of all of the hardware resources that are currently defined on the system. So whether this is the names of the CPCs or the LPARs, the activation profiles, the LPAR groups, the various configuration settings of all of those particular entities, and to be able to have a hardened copy of what my configuration looks every day, for example. So I can list all those resources available. I can connect to one or more of those entities so that I can then query a bunch of values. So for example, things that might be interesting. I want to see what level of microcode I have installed on my hardware. I want to know what the processor configuration is, the operating systems and the status of each of the LPARs, all the LPAR values, defined capacity, processor weights, all the activation profile attributes, LPAR group values, etc. I can set some of these values. I can query more things than I can set. Some things are not settable, other things are. And there's a list within the BCPii publication of all the things that you can set. You can also issue powerful commands. I can issue operating system commands to any operating system, not just zOS. This is really cool. I could direct from a zOS application to a VSE or TPF or a Linux or VM operating system, an operating system command over there. I can deactivate an LPAR, I can re-IPL an operating system, etc. And I can also register to receive events when something happens. So these are unsolicited events. I'm not actually, my BCPii application actually isn't causing these things to happen, but when something outside actually does occur, I want to know about it. And so you can register for those and you'll get a push notification from BCPii that that particular thing has occurred, and maybe you'll then take an action through your application program. So there's two flavors of BCPii requests. So for the last, I would say about 13, 14 years, how long BCPii has been around, we've had these traditional set of BCPii APIs. These APIs allow you to do the methodology that I just talked about in the previous slide, where I can list resources, I then connect to that particular resource, and then I either do a query set command or further lists to be able to drill down. These are proprietary APIs that are provided with zOS that you go look in a manual that zOS provides lots of samples for in SampLib or in GitHub to be able to understand. A thing that has come out in the last few years is something called REST-enabled BCPii. This is using a single service called the HWI REST service. This REST service allows you to really construct your request in terms of a traditional REST interface. So what you're going to do is you're going to specify a HTTP method. So you're going to say a GET or a POST or a delete type of request. You're going to specify potentially query params. You could potentially set request headers. The data that comes back is in JSON format, and it has response headers that can be included. So it looks very much like a traditional HTTP REST programming interface. Another nice thing is that there's a set of services that are available called the HMC Web Services API. That is a REST interface that allows people to programmatically affect hardware changes through an external network through REST. So I can get all of those benefits of the HMC web services API, but not expose myself to an external network and be able to do it internally. So this is a really cool enhancement that's made. And with this REST-enabled BCPii, a whole lot of additional windows into the more hardware features, attributes, and commands is made available through this REST-enabled BCPii. So a little bit more on this newer interface. So if you went into the Hardware Management Console Web Services API publication, you go into Chapter 11, pretty much every single thing, a construct that's in there, I can also create the same interface via BCPii. And again, it's the same internal transport to the support element. It issues the hardware instruction. It does not use a TCP/IP network. You're not opening your HMC to a potential security issues or whatever. But you are now you have all the benefits of that REST API interface, but using the internal interface instead. So again, what's nice about this is that going forward, all new hardware attributes will be automatically available with this interface. There's no need to wait for a corresponding PTF from zOS to be able to enable new hardware features. The documentation is in a single point, so it's all in the Hardware Management Console Web Services API publication. It is a more intuitive for especially early tenure folks to be able to set up this interface. You're dealing with JSON instead of dealing with a more proprietary interface. And the command interface, that thing that I can do to like re-IPL an image or to activate LPAR, et cetera, is much simpler than in the old style. And I can code it up much quicker than I could with the traditional. Okay, so that's all we're going to talk about in terms of the interface. Let's talk about how do I install or activate it. So installing or activating basics. The first thing is the system automatically tries to start the BCPI address space at IPL time. You don't need to add anything to a list of applications that need to start up when you IPL. It's automatically going to be started very early during the IPL. So it's called during master scheduler initialization time. It actually will attempt to start up. Now, a successful start of the address space is going to require that you have done certain steps to configure BCPii. If you try to come up with BCPii and you have not done the necessary steps, it'll attempt to start and immediately it'll say it came right back down because it does not know how to proceed, doesn't even know how to communicate to your local support element. So we have to do a little setup on the HMC and SE in order for the BCPii address space to come up. And we also have to do a little setup in zOS, and we have to do a little setup with the zOS security authorization. So these are usually 3 distinct personas within your shop. So the guy that has control of the HMC SE is probably not the same as maybe the woman that has authority as your zOS sysprog, and which is not the same as your zOS security authorization, your security admin. So again, the setup on the HMC, I have to enable BCPii on the CPC. We'll talk about that quickly. And we have to set up the security controls about which LPARs. If I'm running an application from LPAR A, what other LPARs am I be able to access? Can I access the CPC controls itself, or can I only access the LPAR controls from my own LPAR? All those things can be set up by the HMC engineer. The zOS sysprog just needs to make sure that your application is an authorized APF authorized library, and that BCPii has access to the necessary operating system programs. And then from a security admin perspective on zOS, what sets of entities am I going to allow BCPii to be able to access? Okay, let's continue. Whoop. So this is just a simple screenshot of what it looks like. And so the first thing I do for the hardware perspective, he's going to go into customize API settings. You usually require to have a special authority on the SE in order to be able to visualize this customized API settings interface. And when you go into customize API, so like ACS admin, for example, when you go into customize API settings, you're going to have to go into and click on, check the box that says SNMP. Now you say, why on earth does that have to do with BCPii? Well, BCPii uses SNMP under the covers, and if you don't enable SNMP, you will not be enabling BCPii. So by inference, enabling SNMP is enabling BCPii. You're also going to have to do something called adding a community name. This community name is nothing more than a secret word that operating system and the hardware need to know. So it can be anything. It's really zero security as far as I'm concerned. So this would be the equivalent of, for example, if there's a wireless network that is in my I don't know, let's say it's in my hotel room, but they did not broadcast that SSID, the SSID of the wireless network. So if I know the SSID, I'm in. But if I don't know that SSID, I'm not in. So it's the same thing as this. There's a word that you have to define in the hardware, and I have to have that same definition defined in zOS, and then they just say, okay, he knows the secret handshake. So I recommend, there's so much other security that's in place already that in my mind, I would just use word BCPii as my community name. Of course, you can name it whatever you want. You have to set this up. So this now enables BCPii in the CPC. Once you've enabled these changes and you say, click OK here, now I've enabled BCPii. I still can't do anything though. I now need to go on Z14 and higher. I need to now say which LPARs I'm allowing to access which other LPARs. And I'm really, for the sake of time here today, I'm going to just focus on these PDFs are available to you. You can look at these later on. This is basically saying which LPARs are able to access the CPC controls themselves. For example, if I had the Coke and Pepsi, I don't want Coke or Pepsi accessing the CPC controls themselves that are over the whole mainframe. The Coke doesn't need to know what serial number my mainframe is, for example. That's just a really innocuous thing, but it doesn't really need to know it. I'm not going to allow the applications running from the Coke LPARs to access what the serial number is of my computer, but I will allow Coke to be able to access related things to its LPARs. So that's where I can have the distinction. So again, I can specify either specifically particular LPARs or a group of LPARs. So I have lots of functionality here. And then this is allowing which LPARs I'm allowing to which other LPARs. I go into logical partition security. And with this BCPii column here, I can click on this hyperlink. And when I click on that link, it's going to take me to where I actually specify the authorities of one LPAR to another. This is where I say Coke can only access Coke LPARs and not Pepsi. And again, I can say whether they have the ability to receive commands from other LPARs, whether they have the ability to actually send to other LPARs. And I can also do that same thing for activation profiles as well, which activation profiles I'm going to allow or not allow the system to access. From a zOS sysprog, there's two things they need to do. They just need to make sure that two data sets are in linked list, and they need to make sure that any application that is going to be issuing a BCPii API, that application, the data set that application resides in, is in the APF authorized library. And so they're going to make definitions to, for example, a prog.xx parmlib member or an IEA APF parmlib member to be able to facilitate and add that guy as an authorized application. So really, this is the zOS system programmer can be done with this operation in the matter of like a minute, provided they have the right authorities. The security definitions by the security admin, on the other hand, I'm going to first have to give general BCPii authority, and this can be done again with RACF, ACF2, or top secret. They're going to specify a particular profile in the facility class to basically enable BCPii for a particular user. That basically just says this user can use BCPii or they cannot use BCPii. This is very convenient when I want to be able to remove someone immediately from using BCPii. A single profile disables all access to BCPii immediately. So if they have 10 different profiles about very granular controls, everything. And I don't have to disable all 10 of those controls. If I just disable this one for a particular user ID, that user ID can no longer access BCPii. And then the granularity. So for a particular user, which set of entities can that user access? And so can he access a particular CPC? I might have many mainframe boxes on my machine. Which CPCs can they access? Within that CPC, which LPARs can they access? So in this case, I would specify the form of, this is the SNA form of the CPC name. So once I have that, I'm going to specify the name of the CPC dot the name of the image, and what kind of authority do they have to that particular image that resides on a particular CPC, etc. And then I'm going to choose the particular, when I give them authority to that particular profile, I can give them read, update, or control authority. Read update says I can issue these sets of services to that particular entity that I'm defining. Update authority allows them to do a set or non-operational post requests, and then HWI command allows or HWI rest operational post requests. I need to have control authority, the highest level of authority. So I may wish to be able to change processor weights, but I don't want them to be able to re-IPL. So I can set them to have update authority, for example, instead of control authority for a particular user ID. And then last but not least, remember that secret handshake that I need to just know what the name of the community name is that's been defined by my hardware engineer. So in this case, I need to specify that. And the way I do that is on the actual profile definition for a particular CPC, I need to specify that community name in the form of an Apple data. And so this is an example of a RACF command that would allow me to add the community name in the RACF definition, so that when BCPii communicates to that particular support element, it has the correct handshake, so it knows that I have the password to be able to get into that CPC. Any questions about how to set up BCPii so it works? Great thing about that is that if I have the system IPL'd, I can do, and BCPii tried to come up, it didn't have all the definitions and it came right back down. I can do all those configuration changes, and I can just simply say start HWI start again, and it will try to start up again. And if you've done all the configuration changes now, it will just automatically come up. No need to re-IPL again. Even though BCPii tries to start up an IPL, it allows you to also start it via a proc. So this is quite convenient. Any questions about configuration of BCPii to get it out?
I don't think there's any questions about that specifically, but we have got a couple of questions. Not sure if you want to leave them all to the end because they're kind of variety.
Sure. Let's answer the questions here. I'm not here to hear myself talk. I'm here to help people understand. So sure, feel free.
Yeah. Okay. The first question, it's from David. It's can BCPii be used, for example, to toggle PCHIDs online, offline?
Okay, so the question is, can BCPii use to toggle PCHIDs on and offline?
Yeah.
So I believe the answer to that one is not currently. So there are some things related to the IO infrastructure that are not able to be accessed with BCPii. So I do not believe that capability is available for BCPii. Sorry about that, but that's not currently available.
Thanks, Steve. Next one is from Tim. Are there any new facilities in zOS 2.5 to investigate the health of the BCPii A/S, i.e. the length of queues with ENF events waiting?
Okay, wow. Okay, so this is someone that knows a BCPii. Very good. So are there any facilities in zOS 2.5 to learn more about the health of BCPii, or learn about requests that have been ENF notifications? So BCPii, first of all, so remember BCPii, there is an address space there. So right now, the only way you look today for the health of BCPii is you can go look at the started task like for example, in SDSF and look at the job log and see if there are any messages that BCPI has put out related to its health and status. Very few messages appear there. The question is there like a display command that would show what's the connectivity of current connectors on the address space, what's going on with the address space itself, and then is there ability to view the ENF facilities there. So there is an open requirement that has quite a few votes in it, and I would encourage you to look at the tool. I don't know if you guys are familiar with the AHA tool. That is a way of be able to make requests into IBM for enhancements. And I would encourage you to vote on that display BCPii command. That's been out there for a while, that request. And there is an idea of being able to display. It's been out for probably a number, I don't know, maybe even a couple of years at this point. Vote on that request to get that request to give a higher priority to that. We've already done some design work about what exactly that would take to implement such a thing. And so we would like to have additional capabilities to have a windows and more insight into the health of BCPii. There is some resiliency stuff that is coming, not available yet, and I don't want to pre-announce anything, but there is some resiliency function that will hopefully provide better visibility to when there are issues where the support element was, for example, rebooted. When you had a microcode update and need to reboot the SE, there's a temporary communication gap in that space. And right now, BCPii issues some amount of ENFs when that does occur, but there is some additional capabilities that we would be more resilient when the SE is down for some time and we don't require a program to take any special actions when that does occur. So the answer is, in short, is no, there is no current additional display command in 2.5. It would be nice if they had delivered that then, but if we'd like to see that, I would encourage you to go out to the AHA tool and to be able to vote on, look for BCPii requirements as part of the base control program, the main zOS MVS operating system. And under there, go search for, you can probably just search in AHA for BCPii and find the display command. And I would say vote for that one pretty strongly.
Brilliant. Thanks for that, Steve. Next one, which is from Philip. Will the new features, i.e. new data / commands, going forward also be added to the old interface, HWI query, or only to the new REST interface?
Okay, that's a really, really great question. So, right. So going forward, the idea with BCPii is that we are going to be using the REST API interface for some new functions. So this is exemplified when we delivered functions for example, have a much more visualization into the storage that is being consumed by individual LPARs that is installed on the entire CPC. And going forward, like, for example, that was a new feature that was introduced with REST API, the REST API interface. The idea is that BCPii doesn't want to get in the business of having to ship lots of PTFs whenever there's a new level of hardware, but like would autonomically be able to just inherit those new features when they arrive. So as soon as you get the Z16, that new features would automatically be available through the operating system without having to apply any PTF. So the idea is going forward, all of the new functionality is planned to be exploited through the REST-enabled BCPii service and not through the traditional service, and not rolled back to HWI query, HWI set, HWI command. Okay.
Fantastic, Steve. That's the last question for the moment. So yeah, if you want to, I mean, I think.
Okay, I'll wrap up. I know we're at the top. We're at the top of the hour here. We'll just talk very quickly here, and then maybe just take one or two extra minutes. So again, you can start the address space. If it didn't come up, you can start it. You can stop the address space if you need to apply, for example, emergency maintenance of some sort, or if for some reason you just need to bring it down. There is a stop command that will allow you to stop the address space as well. There's an ENF signal that's broadcasted that says that the address space is up or down. And here's exactly the thing that we were talking about. There is no current console command to check the status and health of BCPii. So one of the folks there really read into my slides here. It would be nice that if we have that functionality, and we, like I said, we've done some initial investigation about what that would entail. And again, you want to check to make sure the BCPI is active. Another way you can check today, unfortunately, you have to use an API. You can do any BCPI command. If it's not available, you'll get a very specific return code that says it's not available. And then again, this is what you're looking for when you start BCPI, that BCPI is active. When you're debugging problems, one of the ways that we first do is, of course, looking at the individual BCPI's API's return code, and there's within that API, there's a diagnostic area that does provide a little bit of data. With the HWI REST, there's a lot more diagnostic information. So we are very verbose. We actually have JSON text that comes back, that in addition to a traditional HTTP status code that will come back, like forbidden or bad request, traditional HTTP things, there'll be a pretty detailed explanation of exactly what's going on in text. So that's more akin to the way a REST API is done. So I would say that HWI REST interface has a far superior diagnostic return capabilities than the older version does. From a system programmer perspective, you can turn C trace on for additional C tracing. There is some minimal C tracing that is always captured, and you can, if you turn C trace off, for example, or you take a dump of the address space with C trace turned on, it will automatically have those C trace records in the dump that then that can be viewed by either IBM or even by the local sysprod. There are system records that are also cut, and support element tracing. So if you have access, if you're a hardware engineer, you can actually, if you have one of these no he said, she said type of situation where I think BCPI sent it, nah, the hardware never got it. Well, you can prove it by looking at the hardware tracing in conjunction with BCPI on both sides to see where the problem might exist. Very rare that you ever need to do that. In all my years, I've only heard a couple clients that have ever had to do that for some very bizarre types of errors, but the capability is there for you to be able to see it. And last but not least, there's all kinds of reference material. We talked about the main source of documentation is the Callable Services for High-Level Languages publication. And there's also, with this new HWI REST service that we were just talking about a little bit about, all new hardware attributes and commands going forward will likely be in the using the HWI REST interface. That REST interface and the data models that REST interface uses are all described in the Hardware Management Console Web Services API publication, Chapter 11, and there's also an appendix in that publication that talks specifically about BCPI. And then the rest of these publications all have little pieces of BCPI throughout, including like SMF records that BCPI will cut and many more. Any other questions before we adjourn for today? I know we're a couple minutes over, 4 minutes over, and I apologize for that. Any last questions?
Yeah, that's all right, but going over a little bit. I think virtual, we've got that flexibility, haven't we? So it's nice. I'll give it a couple of seconds, see if anyone wants to ask any questions. Can't see anyone typing at the moment. No, well, I think we'll leave it there, Steve. But thank you so much for presenting for us. That was a fantastic presentation, and yeah, I thank you on behalf of everyone I can't unmute as well. But yeah, please, guys, leave feedback for Steve. You got the session code there. I think you can do it through the agenda on the GSE webpage as well. But yeah, thanks all for attending, and look forward to seeing you in the other sessions, hopefully. And again, thanks, Steve. That was a fantastic session.
Thank you, guys. I hope this provided a value. My email is on the front cover of this. Please feel free, reach out to me, and I'll do my best to answer any particular question that you may have that maybe you didn't have a chance to hear, or maybe just what you want to talk one-on-one with me. That's fine as well. Okay, so cheers. Have a great rest of your virtual GSE. GSE is a great organization, and I'm so glad that they are helping lots of our Z clients to really leverage some of the cool features on the zOS and the mainframe in general. So thanks a lot, and thank you for having me.
Thanks a lot, Steve. Thanks, guys.